Okay, good morning, everyone, and welcome to today's session. Today happens to be our last session. So uh, just now, 3 weeks have gone by, and we've had 5 sessions, including today. So we hope to have a good learning session today, like we've had with the other ones. Before I proceed, do we have any questions from our last session, other than when we upload the recording for that one? So if you have a question, you can raise up your hand, then I'll call you from our last session. For anything that's bothering you in relation to AWS certifications. Okay, looks like no one has a question of that sort. So let's move on. You know me already, everybody here knows me, so there's no need for introduction. Today, we'll be looking at the well-architected framework. We'll also be looking at application integration. So these are services that you integrate with other applications or other AWS services. We'll be looking at management and governance. And then machine learning services and cost management in AWS. Then finally, we'll look at some exam questions, right? So let's dive in. When you start learning AWS, one of the things you see is the well-architected framework. And what it is basically a guide on how to architect or design your infrastructure on AWS, right? So you have 6 pillars, used to be 5, and recently they added the sustainability pillar, so now it's 6. So you have operational efficiency, security, reliability, performance, efficiency, cost optimization, and then sustainability. These 6 pillars make up the well-architected framework. So what is it? What is it? It's like I always get it wrong with my moving my slides, right? So we have what we call general principles, right? In the well-architected framework, it cuts across or is a summary of the 6 pillars. So let's look at the general principles first, and then we'll go and look at each of the pillars, right? So generally, when you are architecting any workload on AWS, you don't have to guess. You don't have to guess. So let's say you want to start an e-commerce application. You don't guess that you have 1,000 customers. No, you have to make that decision based on data. So you could see the last but one says drive architectures using data. So whether it's your capacity need or how you are architecting a specific workload, you don't guess. You use data, you use experiments, or you perform experiments to see what is required, right? And then because the cloud has a pay-as-you-go model, right? Traditionally, you'd have some systems or servers you use for tests, or VMs you set aside for a test environment and all that, right? And it's usually a scaled down version of the actual production system. But the cloud uses a pay-as-you-go model. When you no longer need resources, you can always terminate them. So this presents you with an opportunity of testing your systems at production scale. What this means is that your test environment can be as big as your production system. When you're done with your test or running your stress tests or test at the production scale, you can always terminate those resources. And someone may ask, creating these resources and deleting them, isn't it a lot of work? And that governance and management will look at infrastructure as code. We'll see how you can easily create infrastructure repeatedly, right? Over and over again, use the same template or code to create your infrastructure over and over again, right? And you also have to automate. So I just mentioned the infrastructure as code. It's like the first step to automate your architecture experimentation. You have to do a lot of experiments, right? A lot of simulations. What happens when this happens and all that. Remember when we did the auto scaling group? I did an experimentation where even though nobody was accessing our application, I ran a command that stressed the CPU, that used all the CPU, right? And then we saw what happened when the CPU had that load. So yeah, you can do a lot of experiments. Now, my favorite one, evolutionary architectures, right? So in a traditional setting, architectures hardly change. Or in the past, when you design an architecture for, let's say, an e-commerce platform, it may change only a few times in its life cycle. Or even the changes are just minor changes, right? But with AWS or even with cloud services and with cloud services, you could evolve your architectures, right? So maybe you could start by using VMs and then maybe move to containers, that's just an example. Then after using containers, you could even go serverless. Your architectures don't need to be like the same throughout its life cycle. Then the last one, improve through game days. So game days are simulations, right? So you organize, the IT team can organize a session where you simulate things that could happen in your production environment, and then you'd react to them. So by doing that, you are testing your team, you are testing your processes, you are testing your systems. So in a production environment or in an actual work environment, you do some of these things to see how you respond to some events in your production environment. It's like a false alarm or a fire alarm, a false fire alarm in a building, right? You all go and gather at what do you call it? There's a place you all gather, and then they simulate calling fire service. Sometimes even fire service will come and then behave as if they are quenching the fire and all that, right? So it's the same concept here. You simulate things that can happen in your production environment. Now let's go to the pillars, right? So the first one is operational excellence. And this is basically the ability to run and then monitor your systems to deliver the capability or the business value they have to. Also, under operational excellence, you have what's continuous improvement. So you improve your processes and procedures. So this has to do with learning whilst you are running your workload. So learning means that when something happens, you typically have an RCA and then know what happened. What happened? How did we respond to it? How can we prevent this in the future? So that is learning. And it's a team, it's not one person, right? Everybody in the team should partake in some of these activities to ensure that all these are passed on to the team members, right? So an operational excellence, you have to enable the team and of course your systems to support the achievement of your business KPIs or objectives. Also, you design your systems or architecture with operations in mind. How will it be operated? How do we react to events when they happen? How do we react to issues? And then I mentioned learning earlier. After you things happen, you document, you learn, you adapt also. So that's would that falls under the continuous improvement, where you adapt your processes to respond quickly or better the next time such an event should happen. Now, under security, we treated security as a first session, right? And realized that under each session, there was some element of security. So it goes without saying that security is a very important feature or a very important pillar in the well-architected framework. So you protect your data or information, your systems, your assets, while you are delivering your business value or business objectives. You put in mitigation strategies, you monitor, you perform alerts, or you configure alerts, you audit things that are happening. So under governance, we look at CloudTrail. It helps in auditing. And then also you integrate your log and then metrics with systems to automatically investigate what happened, right? And then you can take an action when certain things happen. So, and as security, you don't only prevent, but you also have to detect. When you detect, you can learn from what is happening. You also have to stay up to date with AWS services and cyber threats in general. So you always have to be up to date with what is happening. Maybe some security events can happen or data breach can happen with one organization. You can learn from that and prevent that in your organization. So we also see learning here, right? Reliability. So reliability, first of all, your system should function as you designed it. It should be able to recover from disruptions. You should be able to dynamically add or remove resources to meet demand. We looked at auto-scaling groups, so this speaks directly to auto-scaling. And then you should be able to mitigate disruptions, right? So for instance, if an AWS availability zone fails, your system should still operate. We looked at some services that help with reliability already. So we move on to performance efficiency. So whilst you're operating your systems or you architect systems in AWS, you also have to look at what's performance. Are your resources efficient? They meet system requirements? Are they over provisioned? Are they under provisioned? And so you look at all these. Also, of course, before you can do this, you need to monitor. So if you have, let's say, 2 instances in an auto-scaling group, and the average CPU utilization is 25%. So average means that averagely both of them are using 25% of their CPU, right? It's not efficient. It's better to have just one, right? One instance that has a CPU utilization of 50%. However, this one instance can fail. So what happens when the instance fails, right? So if it's not critical, then you could use features like EC2 instance auto recovery, where when the instance fails, it's automatically recovered, right? But for the purpose of high availability, you could maintain a minimum of 2. And so maybe instead of 3 instances, all running at 25, you could do 2 for the purpose of high availability. If, like I said, if it's not critical and can do with some downtime, then maybe you could just do 1 so that you use limited resources, right? Because if you have 2, this also ties directly into cost. This particular scenario ties directly into cost and sustainability, because if you are using 2 instances or 3 instances, you pay more than if you are using 2 or 1, right? The more instances you use, the more you pay. Also, I'll come to the sustainability bit. So let's move on to cost. Yes, AWS wants to make money, but also they want you to spend or provision resources that are cost effective, right? So you don't spend more than you have to. So every workload you run, you should look at the lowest price points, right? How can I achieve the same thing without paying a lot? And that's why people use serverless, because you could run, for instance, when you use Lambda as your compute, you only pay for when your code runs. So with that, and you also have a free tier of about 1 million, 1 million watts. The code runs, but there's quite a generous free tier when it comes to Lambda. So instead of running maybe a Kubernetes cluster, you could actually refactor your application to run using Lambda, and you pay less the price. The other services to that help you spend less. So you should look at every architecture decision you make. You should also consider cost. Later, we'll see tools that help us manage our costs. So sustainability, I mentioned, was added recently. This has to do with reducing your energy consumption. So the example I gave with 2 servers compared to 1, when you run 2 servers, basically we are using more energy, right? 2 instances, we are using more energy than when you use only 1 instance. So your workloads, you should consider sustainability, right? You should make sure or have in mind that you want to be a good citizen of the world and use less energy, so that the energy you are conserving can be used elsewhere, and we don't have to generate more energy to support workloads that are not efficient. Yes, so that's the well-architected framework. Quickly, we move on to application integration. These services are tested on the exam there. So when it comes to well-architected, you may not necessarily see, there's no question asking you about the well-architected framework. However, you apply the well-architected framework in answering any architecture question. So they have a white paper and some documentation and other resources online you can read. You read them to make you a better architect, right? Okay. So let's go to SQS. It's one of the oldest AWS services, simple queue service. And the name simple, it's a very simple service. For lack of words. What it is that it's a queue. So we all know a queue, right? We all know a queue. When you want to go and buy food from the food vendor, usually you have maybe 5 people in line, and there's some order to the line. The first person who got there, out of the 5 people, the first person who got there will be the first person in the line. The last person will be at the end. The first person will definitely buy before all the other people. And so that's a queue. When it comes to computing also, you use queue to order data, right? So, or information. So you could have mostly queues, or queue as a data structure would use the first in, first out principle, right? That's FIFO. So the first data that came will be the first one that is processed. Okay, so back to SQS. SQS is a hosted queue service. You don't, it's provided by AWS. So all you have to do is create the queue, and then you can put items in the queue. Now it lets you decouple your applications. So typically, you can use any, let's say any application, right? You have some data coming in. Because you want to make sure that all the data is processed, you can put the data coming in the queue or SQS queue, right? And you have another application. So let's say a customer places an order. When they place an order, you can put the order in the queue. Now there could be a backend service that needs to process the order. So the backend service can pick the order from the queue and process it. Maybe after processing, they send a message to the delivery company to come for it, something like that. Or even send a message to the customer that their order is ready and all that. So in this case, the web application that allows the customer to place the order becomes the producer, right? And then the backend application that processes the order from the queue becomes the consumer. SQS supports standard and then FIFO, which is first in, first out queues. We'll look at what these two are shortly. We've spoken about producers and consumers. So producers will basically send message to the queue, and then consumers would receive messages from the queue. When you store, or when you put a message in the SQS queue, it's actually replicated or stored redundantly across multiple servers, just so that your data never gets missing, or your data is durable, right? Or if one server is not available, that message can still be gotten from another server, sorry. So what's a standard queue and what's a FIFO queue? I spoke about order, right? Or when I first spoke about queue. If you don't get anything from this slide, the most important thing you should know is that standard queues, you use them when you want to be able to read a lot of messages from the queue at a time, right? And then you use the first in, first out, which is FIFO, for when you want ordering, strict ordering, right? So you want to make sure that the order in which messages came to the queue are maintained. That's when you use FIFO. Now, standard queues give you unlimited throughput, so you can make as many API calls per second as you want. However, FIFO queues will allow you to make only 300 API calls. Now you realize that I also have up to 3,000 messages per second. So there's also a feature called batching. Batching means that in one API call, you are pulling a batch of messages, right? Or you are working on a batch of messages. So the maximum batch size is 10. So when you multiply 10 by 300 API calls, that gives you 3,000 messages. So you can process 3,000 messages. Process could be send or receive or even delete, right? So yeah, FIFO queues gives you only 300 API calls per second if you use batching. So 300 API calls will mean 300 messages by default. But if you use batching, then you can get 3,000 messages. So They give you high throughput. 300 is high, right? But standard gives you unlimited, more than. Standard queues would make sure that your messages are delivered at least once. It's possible that your message may be delivered more than once. So it means that when you send a message, it may appear 2 times. It may. It hardly happens, but it is possible with standard queues. However, with FIFO, there are no duplicates. Every message is delivered only once. Standard queues use best effort. So the order may be preserved, but it is also possible that a message which was sent later would arrive earlier than, or will be in the queue before a message that was sent maybe before the previous message we spoke about, right? However, FIFO queues would ensure that the order is preserved. So these are the differences. I've spoken about when to use both already. So there are some terms or other things you should know when it comes to SQS, right? And the first one is visibility timeout. So when you send a message to an SQS queue, what actually happens is that after a message is put in the queue, a consumer can come and read messages. When a consumer comes to read messages, now those the messages or message the consumer has read will not be visible in the queue again, right? So if another consumer comes to read messages, they won't see the previous message that was read. This is done to prevent processing messages more than once, right? Or to prevent duplicate processing, right? So whilst the consumer processes the message is not visible in the queue. Now, after the consumer processes the message, they have to delete the message so that it is not processed by another consumer or by the same consumer. So the visibility timeout is the time that, or the time duration that the message becomes unavailable in the queue, right? It's not seen in the queue. So you could set it to be 0 seconds up to 12 hours. The default is actually 30 seconds. So whilst when a message is picked up, whilst it's being processed, it becomes invisible for that time period. Now, an SQS message is retained for a maximum of 14 days. I think the default is 4 days or so. And you could set it to any number of days, right? So you could have a message in a queue for as long as 14 days. SQS messages can be up to 256 kilobytes. If your message is more than 256 kilobytes, then you can store that message in maybe S3, and then you reference it in the SQS queue. So you have a pointer in the SQS queue to the pointer would definitely be the URL for the object in S3 or the item if you store it in DynamoDB. So when your consumer picks the message, they see the reference, and then your consumer is programmed to go and pick of course, and needs to have the access to be able to go and pick that item from S3 or DynamoDB. So I want to ask a question here. I said that if your message is larger than 256, you can store it in S3 or DynamoDB. What's the maximum size of an object in S3? Or what should be what's the largest object you can store in S3? The size? Anyone?
5 TB.
5 TB. Who gave that answer?
Foster.
Foster, okay. Daniel, I see your hand up. What do you think is the largest object size in S3? Daniel, I'm waiting for you. Okay, chat. 5 TB. Everybody's saying 5 TB. Okay. And then how about DynamoDB? I spoke about it last Thursday, DynamoDB. Anyone?
400 kilobits.
Yes, 400 kilobytes. So it means that if your message is larger than 400 kilobytes, it can't go into DynamoDB, right? So you have to take note. Even though I have DynamoDB here, you should look at the size, yeah, of the message. So what happens to messages that are not successfully consumed or processed? You could move them to what you call a dead letter queue, right? So a dead letter queue could also be a source for another SQS or the same SQS queue. Dead letter queues are not created by default, so you have to create them. So if, let's say, instead of deleting messages after the retention period, it can be sent to the dead letter queue because we are not successfully consumed. Ali, yes.
Yeah, when you read some materials, it tells you that those undelivered messages are put in a queue, but it do not tell you whether it's in a dead letter queue or this particular section. I only say it will be put in a queue. So what are they trying to tell us?
So what you should know is that messages that are not successfully consumed, so they may have been consumed actually, but they were not deleted. Or, yeah, those messages are put in the dead letter queue. What you should know is that you create the dead letter queue. It's not automatic. It's not like when you create an SQS queue, they create a dead letter queue for you. Maybe when we are doing the demo, we'll look at it. And yes, and the dead letter queue can be a source for another queue. So it gives you a higher retention or the possibility, the opportunity to process those messages again. Now we also have what you call short pooling and long pooling. So what short pooling is that a queries, I mentioned data is stored when you put data in an SQS queue, is stored on multiple servers, right? So short pooling would request for or read data from a number. Okay. So you could read data from just a few servers or a subset of the servers for messages in the queue. That's short pooling. It is possible that when you do a short pooling, it will return no messages because there were no, the servers didn't have any new messages, right? However, I want to, the better way to do this is to use long pooling, right? Where you query all the servers and then also you give a time to do the query and also the maximum number of messages to pull. So with long pooling, even when the servers don't have any messages, the pull can, or the request can wait till the timeout you've given, and then maybe new messages will come. So it's more efficient than the short pooling. And yeah, I mentioned you could specify the maximum number of messages also. Okay, so that's SQS. We'll do a demo on this. Let's look at the SNS, which is related. So when it comes to application integration, there are lots of services, right? And sometimes it becomes confusing. However, it's your, I mean, everybody comes up with ways to understand how they work, right? So SQS is simple queue service. It means that it works with queues. The keyword is queue. All right, SNS, simple notification service. As the name goes, it gives notifications. However, it's not like maybe it's more than the usual notifications we know, right? Even though they're still notifications. Over here too, you have what? You have publishers and consumers. You can think of, publishers and subscribers. You can think of it as producers and consumers also, right? So a publisher, what happens is that to use SNS, you have to create a topic. Then the topic becomes your communication channel, right? So publishers will send messages to the topic. Subscribers would read messages from the topic. So that's how you communicate between different applications. You realize that in SQS, producers will put messages or send messages to the queue, and then consumers will read messages from the queue. However, SNS is you publish your message to the topic, the subscriber reads from the topic. So your subscriber or your clients, when they subscribe to the SNS topic, you can receive your messages. For SNS, you can receive your messages from even SQS, SMS, mobile push notifications, HTTP email, or Kinesis data file host. So you have a lot of different types of consumers or subscribers. We'll do a demo on this also. So SNS is used for application to application messaging, right? So usually you break down your applications into various components. So one component can send data to another component using SNS. You could also do this with SQS actually. I'll explain when to use SNS and when to use SQS, right? You could use this for application to person notification. So I mentioned you could send SMS or email using SNS. So that emails and SMS are read by human beings, right? SNS also supports standard and FIFO topics, the same concepts as the SQS one. So standard is your best effort it's best effort, right? No, you don't do much to send your messages in the order they came. But FIFO would ensure that if you create a FIFO topic, then you need to also create an SQS FIFO queue as the consumer. Message durability. So this is also stored across multiple servers. And you could use SNS to archive your data and perform analytics. So you could, when you use Kinesis, you could use the file host to actually archive your data in S3, or go on to perform further analytics with it. You could filter messages, right? So where you want to see, or you only want to receive messages when they meet a certain filtering criteria. And you could have different attributes in your messages. So maybe different data points. It's secured because you could use KMS to encrypt it. and you access it mobile HTTPS. That's encryption in transit. So let's look at app flow. We said SQS is for queues, SNS for messaging or notification. Now, app flow is for integration. So you have a service outside AWS, a software as a service mostly outside AWS, and you want to bring data from that software as a service into AWS. App flow is your answer. So you basically map the data coming from the SaaS application to where you want to deliver it in AWS, whether S3 or Redshift. Redshift is used for analytics and data warehousing. Yeah. Is it data warehousing? Business intelligence. Yeah. That's all analytics. So for instance, if you have Salesforce opportunities and you want to take them, put them in Redshift tables, or even save them as files or objects in S3, you could use AppFlow to do that. If you want to analyze your Slack conversations, you could use AppFlow. You have support tickets in Zendesk and you want to send them to S3 and then use other AWS services to analyze them. You have data from ServiceNow, Snowflake, all those other services, and you want to move them to S3, you can do that. So you could create a schedule for that. And so it's for integrating applications outside AWS, right? Okay. AppSync. When you hear AppSync, the next thing is GraphQL. So GraphQL is an API querying interface. So when it comes to API, I'm sure most of us know REST, and then those who have been around will know SOAP. GraphQL is an alternative. REST is an endpoint. However, GraphQL, it's a query interface. So like the way you write MySQL commands to query a database, GraphQL actually does something similar, right? It's an interface that can query your data sources or even change the data in them. And you can use it to interface data from multiple places, right? So I think it was developed by Facebook and open source and all that. It's quite new compared to the other APIs, other API types. So in AWS, if you want a GraphQL interface, you could use AppSync. The cool thing is that you can change data in the GraphQL, and then it will reflect in the connected or where it's interfacing the data from. So maybe you have a microservice or you have, let's say, 2 microservices. Their data is stored. One has data stored in RDS, another has data stored in DynamoDB. And you interface these two with GraphQL. If there's a reference from one database type to the other, when you change that attribute in the GraphQL, it would change at both places. It makes it easy. The learning curve is quite high. Yeah, they're not used to that, so it takes a lot of time to learn, but it makes it easy to interface data from multiple sources. So typically in REST, you have several endpoints to perform different activities. GraphQL, you could just perform one operation and then it would be as if you called the different REST endpoints to do different things for you. So it's quite cool, but it requires some learning. all you have to know is that if you want to interface applications using GraphQL, AppSync is what you should use, right? That's caching. You could also use Cognito, user pools for access. MQ. So we've looked at GraphQL, we've looked at notifications, we've looked at queues, we've looked at API integration. Now the next one is message broker. So MQ, yeah. MQ is a message, or Amazon MQ is a message broker service. Of course, it's managed, and it makes you to migrate to a message broker in the cloud. What this means is that in the past, message brokers have been around for a very long time. So you have message brokers like Apache ActiveMQ, and then there's RabbitMQ. So if you have any application that uses any of these brokers, and you want to bring them to the cloud, you could actually use Amazon MQ to do that. So it's for migrating existing applications. If you want a way to communicate between applications and it's a new application, you use SNS or SQS. If it's an old application that is using Apache MQ or RabbitMQ, you use and you don't want to modernize it or refactor it, then you can migrate it to Amazon MQ. So let's look at the, let's note the use cases for it. And below I have listed the protocols and APIs that supports or MQ supports, right? So if you have an old application using Apache Active MQ or RabbitMQ, you could migrate it to AWS with and use Amazon MQ. It will support, it will work as if it was in the same environment, right? If it's a new application, then you use SNS or SQS. Now, to when should you use SNS or SQS? SQS, when you look at SQS and SNS, it looks like you could do the same thing with either of the two, right? Either I put it in a queue or you send it as a notification. Now, SNS has a feature that SQS doesn't have. That feature is called fan out. So fan out is you delivering a message to multiple consumers at a time. Remember when we looked at SNS, right? We said you could have subscribers. So one SNS topic could have multiple subscribers. And that message is sent to all of them at the same time. So for instance, when I create an SNS topic, I could set an SQS queue as a subscriber, at the same time set an email, my email address as another subscriber. So when a message drops in the topic, the SQS queue, the message will be sent to the SQS queue. It would also be sent to me via email. I could have a Lambda application as well, receiving the same message. Like it's endless. So you could use that one message and then duplicate it to multiple consumers or subscribers. SQS, you need to use APIs to, so you could have multiple consumers actually on SQS. However, remember I said that only one person, you want to make sure only one person process the message at a time, right? And usually the consumers are all the same. So maybe you have an auto scale, EC2 instances in an auto scaling group running the same application. Yeah. However, with SNS, you could have different application types. So that's like the main difference, or one thing SNS can do that you can't necessarily do with SQS. Event bridge. There used to be a service called CloudWatch Events. It's still there actually. And that has been rebranded to Event Bridge with more features. So what's Event Bridge? So it's what they call an event bus, basically a container for events. An event is any change in your environment. So if I start an EC2 instance, it's an event. If I stop an EC2 instance, it's an event. If I upload an object to an S3 bucket, it's an event. If I delete an object in an S3 bucket, it's an event. If I transition an object from standard to standard infrequent access, it is an event. Okay. If I create a VPC, it's an event. Okay. So events bridge will basically deliver events from your application, AWS services, or even a software as a service to targets in your AWS accounts like Lambda or an SNS topic to be a target, right? And yeah, so that's what it does. You'd use rules to define the targets and the filtering and all that. So when events bridge receives an event, you configure all this, right? When it receives an event, it applies a rule to it, and then based on the rule, it routes it to the target. We'll do a demo on this. So what's the time? It's 10:57. Let's take our usual 10 minutes break, and then when we come back, we'll do our demo. Our demo will be Event Bridge, SNS, and SQS, just to show you how application integration works, even among the services that support application integration. 10 minutes time. This is what I've been using, so let's go. So we'll be back.
Yeah, Ima. Iva, let's chat.
I heard my name. Edwin, was that you?
Yeah, I was saying that. Yeah, I think I didn't edit the title, but the link was different. It's
Okay,
different.
okay. That's
Yeah.
fine.
Okay, all right.
Okay, so our time is up. Our break time is up. I said we'll do a demo with Event Bridge, right? So let's start. Event Bridge. It used to be called CloudWatch Events. So let's look at event buses first of all. There's a default event bus for every region in your accounts, like you can see here. You could create custom event buses. I mentioned rules. Rules are associated with the event bus. So every rule applies to one event bus. So let's put a rule called Bootcamp. And then we won't create a custom event bus. We use the default one. Then you can create the rule type could either be based on a pattern or a schedule. So a schedule is like a specific time. A pattern is when something happens, or yeah, we'll see what that is actually. So I want to use the source is AWS events. This event would only be from AWS. You could also, if you want to use the Event Bridge partner events, you could also select this one. I'm going to create one that would be for AWS events. So AWS events, I could get sample events. So let's say if I want to do EC2, this is auto scaling related. I could just do EC2 state change. Okay. So this is the pattern I need to use if I want. Okay, we are back. Let me share my screen again. So yeah, I was saying this is a sample event. You could also choose another event. So let's select 5. This one is shutting down. So these are sample events. I've not selected anything. I'm just showing you that this is a sample event. You could copy it actually. I want to get lots of events, so I won't limit it to only a specific state. So let's proceed and see. AWS service, I'm going to select C2. And then the type, I want instance state change. So this will take care of all the state changes. Realize that this has a specific state, but I'm not going to specify that. So it will give me all the state changes. I could also select specific instances. I want it to be all instances. So let me test the pattern to see if it's valid. It says yes, it's valid. Okay. Now I could go ahead and select next. What should my target be? So this is where I want to create an SNS topic. Remember I said SNS supports fan out, so I could use multiple subscribers. So let me create an SNS topic here, and then we'll come and select it as our target. All right, I have 0 topics in my account. So I could come and create a topic. Let's use standard. Then we select. So all the things I spoke about, you can actually see them here, right? See them here. The FIFO only supports SQS FIFO Q. All right. So I'm not selecting FIFO. I want to select Bootcamp topic. And then access policy is very important. Let's look at what we have here. So by default, the topic owner has access, and then the topic owner can also subscribe. So this was created by me. So yeah, by default, see the account owner here. If you're an IAM user, you need to be given permissions to access this. Okay, so this is okay. Let's see who can publish. Okay, this is AWS. So, okay, that's fine. I think that should be all. Now let me select the topic name. I'll also make it Bootcamp topic. Okay, I said by default, only the person who created this can publish and subscribe by default. Okay, so let's create this. And you saw the permissions as the condition says source owner should be this. So this is your admin or the person who, and your admin, and then the root owner, and then the person creating this. Okay. Now let's create a topic. We have our topic. Let's select AWS service as our target, right? So let's select SMS topic. Now I have to go and select the topic. Bootcamp topic, yes. So now let me connect. And then next. Okay, so this is a review of everything I've selected. Let me create the rule. All right, let's go back to SNS and look at our access policy now. Let me. Okay. All right. So realize that now I have a new statement here. This wasn't here before. And this is coming, this is allowing the Event Hub service, events.amazonaws.com is the URL for the event service, right? So, and then we are giving it permissions to do SNS publish on the topic we created. So by linking or selecting my topic as the target, AWS automatically updated the access policies so that EventBridge can publish to the topic. What type of policy is this? This I think I'll mention names. Good to mention those who have been here for long. Who has been here for Nana Enim? I don't think Nana Enim was in our first session. But do you want to try?
No, I wasn't in the first session. No.
Elwood, I see you. What type of policy is this? Ayeka. This policy is on the resource.
Okay.
Other policies, you give them to identities, but this policy is on a resource. Okay, so Nana Eko wants to answer this.
Resource-based policy.
Yes, you see, I was giving you the answer by saying it's on a resource. So this is a resource-based policy, yeah. Okay, good. So we have access to publish from events, but that's good. What's the next thing we will do? We said we wanted to create an SQS queue. So let's go and create an SQS queue. We started by creating an event bridge rule, and we created an SNS topic. We selected the SNS topic as our targets for the event bridge. Now we're going to create an SQS. I need to mute somebody. Who else? Okay. Now the SQS queue is going to be a subscriber to the topic. Okay, so standard, yes, and then we'll select our bootcamp. You see our visibility timeout here. Our retention period is set to four days. I mentioned that we could set it to 14 days. We could also make it what? 300 seconds, 3,000 seconds. Okay, that's a few hours. That's the message size. Yep. Now, access policy. You realize that the account has access to do all SQS actions on this particular resource we are creating, because our queue is called Bootcamp. Okay. All right. So by default, if you're an admin or the root account, you're the only one who have access to this. So we'll come back to this. Okay. Now you see our dead letter queue, right? Send on deliver messages to a dead letter. Yeah. So it's disabled. If I enable it, I have to go and create another queue or choose another queue that will be used as a dead letter queue. I don't need this, so let me disable it. Let's create our queue. Now, the easiest way to give our SNS topic permissions to this queue is by coming to the topic, and then let's go back. If I select this and I say, sorry, I rather have to do it from SQS. So let's go back to queues. When I select this, and then under actions, I say subscribe to SNS topic. You realize I can also configure it as a Lambda trigger. Okay. So we select our bootcamp topic, right? So that's the queue. Now that I'm saving this, you realize that I'll get, when I go to access policy, a new policy should be created to allow the SNS topic. Looks like I have to reload this page. So access policy. Good. So you realize initially this was the only one there. This was the only one there. Now there's another one, topic subscription. Good. It's also allowing, this is every AWS service. That's what it says. Okay, that's fine. However, we have a condition which says the ARN should be this. So in effect, this is the only allowed entity that can use this particular permission. This is also a resource-based policy. Okay, so now we have access. Just to confirm that we have access, right? Let's check our topic and then go to subscriptions. So you realize now my SQS queue is a subscriber here because from SQS, I said I should subscribe to this topic. I could also have come here and created the subscription. Okay, so just to test this, right? I'm going to publish a message here. Bootcamp test message. Just to make sure this works. Some message from the console. Okay, I can publish this message. And let's check SQS. Let's go back to SQS, select this, and then we'll select send and receive messages. So in real life, this is not how you publish messages and retrieve them. You'd actually publish them from an application or an AWS service, and you have another application as your consumer. So you have maybe an application running on EC2 instance. That would actually come and pull the SQS message, right? So you come and pull the SQS queue. So we have a pooling duration of 30 and a maximum message count of 10. So this is actually a long pull. Let me edit this so it's quicker. Let's make it 5 seconds. And then save. And then now let's pull for messages. So realize I have a message here automatically, okay? This is how it looks like. Realize I said what the subject was Bootcamp. So the subject is Bootcamp test message, and then this was some message from the console. That's what I typed in, right? Okay, so that's fine. Let's leave this. Now, event bridge. Let's do one other thing. Let's go to SNS, right? And then add another subscription just to test the fan out concept. So why I select what I want. So let's make or email. Who wants to receive an email? Who wants to receive our emails? Okay. So that's fine. I can save this. Okay. So now we have 2 subscribers. Let's check. Should have 2 subscribers. One is our SQS queue. Okay, so when you use email, you actually have to confirm. So let's quickly go and confirm the email. You have to confirm before you start receiving emails from SNS. So let me quickly do this. So now I have to 11:25. Okay. So I have to click this and show that. So subscription confirmed. Now I can go back to SNS and then reload this. It should show that I should be able to receive notifications from SNS now. So yeah, it's confirmed. Good. So when you use an email, you have to confirm first. Okay. Our events bridge rule said that we'll respond to EC2 status changes. So let's go and create an EC2 instance. Okay. This instance, all we are doing is checking the status changes, right? So I don't need to do anything fancy with whilst creating it. I can leave all the defaults and then we just create it. So Bootcamp. Okay. Yeah, keeper, I have to tell them that I'm not going to use any keeper because I'm not going to log into this. And then I can launch this instance. And now let's see the instance. Okay. So now my instance should be, it's in a pending state. Okay, that's good. Let me check my email and see if I have a new email. Yes, I have a new email. We have to check the time, right? So this is the latest, 11:27. What does the email say? It says EC2 instance state change notification. Source is AWS.EC2. The account, the time, the region, the resource, instance detail, and then the status is pending. So that's when we saw the status as pending. Now it is running. Running means that the status has changed. So I should receive a new email. There you have it. Now you see the status running, right? So this was sent to my email. Let's go and pull for SQS messages and see if we would get the same message. So realize that I have 2 additional messages, one at 11:27, the other at 11:28. So I guess this one is when it was in the pending state, and this is when it's in the running state. So let's check the pending state. And you realize, let's see, pending. Yeah. And now this should be the running state. Running state is running. So maybe you have we said AWS, or we'll see later that AWS monitors or logs all the events that happen or API calls that happen in your environment. But these are API calls. EC2 instance change. When you create an EC2 instance or you terminate it, it's an API call. But a status change is not necessarily an API call. As if you change from pending. When you create an instance, the state is pending, then it moves to what's running. So that those 2 states are not necessarily API calls, but it's creating the instance or stopping the instance or terminating it. Those are the API calls. They also happen to be instance states as well, right? So yeah, you can use Event Bridge to collect some of these information, right, for other systems. To collect some of these events to other monitoring applications. Okay, so that's a short demo. So we use the Event Bridge to send EC2 instance changes to SNS, and then we fan it out to an SQS queue and then an email. So when we learned about those scaling groups, I think somebody asked about how are you notified and all that. You use SNS, you can use SNS or even Event Bridge to handle some of these events that occur in your AWS environment. Any questions? If there are no questions, we move on to management and governance. Do we have questions? There are no questions. Okay. Management and governance. CloudWatch is a monitoring service from AWS. Use it to monitor. Yeah, Joey, go ahead, please.
Good morning. Please, I wanted to find out, is it possible to not use EventBridge, but would solely rely on SQS or SNS for this kind of activity that you just did here?
Yes, it's possible.
Okay.
Yeah, but EventBridge is like a hub for all sorts of events, right?
Okay.
And there are some services you can't directly select the SQS or SNS as targets. So you use the Event Bridge to interface that. Okay, CloudWatch. So I mentioned that it's a monitoring service from AWS. It can monitor your AWS resources as well as your own applications you run on AWS or even on-prem. So you can use CloudWatch to collect and then track metrics. You can use, by default, it displays metrics for all AWS services in your account. If you want, there are some default metrics, right? If you want custom metrics, I think you can use enhanced metrics. You pay for that one. The default ones are free. The detailed monitoring would also send you metrics at a 1 minute interval. The default one is, I think, 5 minutes. So you could also create alarms that would watch metrics, and then you can send a notification when a threshold is reached, right, or breached. So let's look at what metrics are. Metrics basically are data about performance of your system. So when we're creating the auto scaling group, using the dynamic scaling policy, we said that we wanted to monitor the average CPU utilization, and that's a metric. So you could have other metrics like number of IOPS on your, or use that IOPS on your, or IOPS per average IOPS on your ABS volumes, among other things. DynamoDB table, maybe the number of writes or read capacity units and all that. Metrics for almost everything, right? So there's also what you call the CloudWatch metrics insights, and this is basically an SQL query engine that you use to query your metrics to get insights from. And CloudWatch metrics would have your historical metrics. It would also have the current ones, or the real time, what's happening now. So you could check trends of your metrics. Also, metrics are stored for 15 months. Yeah. We spoke about alarm earlier. So alarm is basically saying that you should tell me or perform an action when a certain threshold for a metric is reached. So an alarm status could be okay. It means that you've not gotten to the threshold yet. If it's an alarm, then it means that you've reached the threshold. Insufficient data means you don't have enough data to report. Then CloudWatch logs. We all have an idea about logs, right? I think last week we looked at the logs for VPC flow logs, right? Yeah. So other services also publish logs to CloudWatch. You can use what they call CloudWatch logs agent to publish custom logs from your own application into CloudWatch. So CloudWatch is like a centralized monitoring system. Supports metrics, it supports logs, there's visualization, there's alarms, all that. Okay, so a log event is basically some activity that is reported, right? So maybe user signs in and the sign in was successful. That's a log event. I mean, you have data with all that, maybe the user's IP address, the time they signed in, whether it was successful or it failed. So a log stream is a sequence of log events. So like your application, if your application, you are taking logs for your application, all the logs coming from the application becomes a log stream, right? Then a log group is just a grouping of log streams with the same retention, monitoring, and then access control policies, right? So that's about CloudWatch. It's quite huge. I've just tried to simplify it into this. So we looked at the CloudWatch service, what metrics are, what logs are, and then what event alarms are. We looked at event bridge under the application integration side. So CloudFormation, what's our time? 11:38. Okay. I think we're doing well on time. So CloudFormation is a service that lets you write code to model and manage your AWS resources. You have our infrastructure as code, infrastructure as code, infrastructure as code. It's basically writing code, like an application code, and then you use that code to provision your resources. However, CloudFormation can only be used on AWS, right? The other ones like Terraform, which is quite cool. It can be used on AWS and other cloud providers as well as other softwares, right? So, but CloudFormation only works on AWS. It's native to AWS. So it allows you to simplify your infrastructure. When I was talking about the well-architected framework, and I said you should automate or you should even test at production scale. And I mentioned that you can easily deploy your resources and terminate them. Yes, it's not efficient going to the console like we've been doing in this bootcamp. We always go into the console to create resources. No, that you don't do that in production. You write your infrastructure or what you want to deploy as code, and then you go and upload it in CloudFormation. Or if you use Terraform to create those resources. You can use CloudFormation to delete them, or even go and create them in another region or for another environment, maybe production or staging or testing, you know. So you can use one code or one template. You can create it over and over and over and over and over again. And if you want to see you have logs on all the things that have happened. So even if you update your template and upload it again, you have logs on when that was updated and from what to what, right? Also, I think I've combined all of them. It's also best practice to version control your code, your infrastructure as code. By version control, you know, IT applications usually use version control systems like Git to track all the updates that are made. So for infrastructure as code, you do the same. When you want to change your infrastructure, you would change it locally and commit it to a shared repo. And then from the shared repo, it is created. You could even model a CI/CD pipeline for infrastructure, where maybe from a certain branch, you can create it in the development environment. You go through a PR, merge requests to track to check the changes before you can deploy to your production environments and all that, right? So these are things you do in a production environment. Let's look at a few concepts when it comes to CloudFormation. I mentioned that you write code. The code is either so you actually write JSON or YAML templates for this. So a template is basically JSON or YAML file, and a template is the blueprint for your resources. What that means is that your resources are going to be built, or what you write in the templates is what will be used to build your resources. So like an architect, as in a construction or building architect, right, would draw a house or a bridge. Based on that drawing, you'll go and the contractors would go and implement it, right? Build the bridge or the house. The template is the same. It's the drawing that is used to build your resources in AWS. So when you have a template and that template is created, we call it a stack. So that everything in the templates, when deployed, it becomes a stack. So you can create it. You can create a stack from the templates or update a stack that has been created already, or delete it. Delete the actual implementation of the template, right? Change sets, when you have a stack and you want to update it, as you change something in a template. The change set will let you see the changes you are proposing and tell you or give you a summary of the changes, whether it will mean the resource has to be created again or it will be updated. Yeah, and what the impact is actually. Stack sets is your stacks, but this time around, it extends it to other regions, right? So when you create a stack, it's in a single region, the region you choose. But a stack set can be used to deploy the same stack in other regions. So if you want to have your infrastructure in multiple regions, use a stack set. Now, the template has various components, right? It's more than this. I just listed the most important parts here. Now, there's a version, template version. I think the latest is 2010, September 9. Yeah. And it basically tells CloudFormation what entries are supported or the capabilities of the templates. The other versions cannot do certain things, right? So yeah, a description is just a description for your template. Parameters allow you to customize your template when creating a stack. So these are like input values. Anytime you are using the template, you can specify different values. So maybe you want to create an EC2 instance, and then you would use, you create a parameter like maybe instance type. And this will make sure that anytime you are creating a stack from this template, you specify the instance type. So today when I'm using the template, I could say I want to use a t2.micro, right? Tomorrow, I could say I want to use a c5.large. If I don't use parameters, it means that I have to specify the template, the instance type. I have to hard code it in the template, and it means that every time it will create the same instance type for me. But if I use a parameter and reference the parameter, then I could actually change it anytime I'm deploying this a stack. So resources are the AWS resources you want to create. So it could be an EC2 instance, an RDS database, EC2 instance. So outputs are values you want to be returned to you after a stack is created. So maybe if you use a template to create a load balancer, you would want to get the URL, the DNS for the load balancer, so that you can share that with other people to access your website, right? Or your application. So use outputs for that. CloudTrail. CloudTrail is for governance and auditing and compliance, right? So it's a service that logs all API calls in your AWS accounts. So every activity you do, CloudTrail would log it. It will tell you the user, if it's a role, the role that performed that activity. So if something happens or you want to investigate or you want to check all the accesses in your account, you could go to CloudTrail and then all the information is there, right? So like I said, all events, whether I use the command line or SDK or APIs or the console, it's a tracked. By default, CloudTrail will keep this information for 90 days and you can view it in the console. There are different types of events, right? So management events is your typical, so an event is an entry in CloudTrail, right? Something that happens, so an API call. So management events are basically management operations, like you creating an AWS instance, your everyday operations, right? Then data events provides you information about operations performed on a specific resource or in the resource. So if I stop an instance, it's a data event. Okay. Insight event. I see a chat. Okay, I'll answer that. So insight event, this is generated by AWS itself, right? So when an unusual API call happens. So for instance, every day, or Emmanuel logs, or Emmanuel accesses AWS maybe once every week. All of a sudden, Emmanuel is logging into the console every hour, every day, like he's there. That was not happening in the past. Or all of a sudden you create 20 S3 buckets. All of a sudden, a certain IP in Bangladesh is downloading objects from your buckets, which never happens. Maybe all the time, there's only one location that objects are requested from. So there's a question on, or I'm asked to give more clarity, right, on CloudWatch logs and CloudWatch trail. CloudWatch, okay, so let me say what a trail is before I go to CloudWatch trail. So a trail basically lets you send your events to S3 buckets or CloudWatch logs, or even CloudWatch events or events bridge, right? So I mentioned that all the CloudTrail events can be viewed in the CloudTrail console. It has events spanning the last 90 days. If you want to store these events for a long time, then you can move it to S3 or CloudWatch logs. A trail is basically you moving, a trail contains CloudTrail events, okay? CloudTrail events are API calls you have made in your AWS account. Any user, any role, yeah, have made in their account. CloudWatch logs are logs from applications or your resources. So I spoke about custom logs. So if you run an application that logs everything that happens, this is what is happening in the application, right? Someone tried to log in, someone viewed their cards. Those are logs, or they're trying to make an API call to an external system that didn't work. You log it and push it to CloudWatch logs, right? So I don't think I have any logs enabled in this account I would have showed you. It's just an entry of, hold on. CloudWatch. So the key difference is that CloudTrail is API events. CloudWatch is any form of logs from any AWS resource or an application you have on AWS. So I don't think I have a log. Quite a quick one, right? No, it becomes a long process. It becomes another demo altogether. Okay. So let me give you an example. When we did the VPC flow log is an example of logs that can send to cloud watch logs, right? What it does is basically accesses to your VPC or a network interface in your VPC. So let's say Emmanuel we have a load balancer in your AWS environment in the VPC. I tried to, I entered the DNS of the load balancer in my browser. What that means is that I'll actually go into the VPC, or my data will traverse the VPC. So the flow log will log it. Maybe source, my IP, destination, the IP of the load balancer, was it allowed or rejected, the size of the traffic, and all that. That's a log. So that's a log. It's not an API call. I'm trying to do a network access to the load balancer. However, API calls are me interacting with AWS resources. That's if I create a load balancer or I add a listener to a load balancer, that's an API event. So that is CloudTrail. Is that understood? It's good you asked this question. The key differentiation is CloudTrail is API events, logs is every other thing. A trail could actually be a log. Like you realize we could push CloudTrail events to CloudWatch log, right? But CloudTrail's focus is only on API calls. Okay. So let's look at CloudFormation. What's the time? 11:55. Okay. I think we could quickly create a CloudFormation. So last time we tried to create a database, right? A DynamoDB table. We tried to create it in the UI. So let's use CloudFormation to create that table. So let's see. Can you see my VS Code?
Yes.
Yes, we can.
Okay, good. So this is the template format version we spoke about. The description, you have parameters. So this is in JSON. You can write this in YAML. We have our resources, and then we have our outputs, okay? And let's look at the resource first. So I'm creating a resource called Dynamo, the type is DynamoDB table. I need to define the properties. And properties here are the attributes definition. So I'm going to define one attribute, which is my primary key or partition key. And then I have to specify a key schema also. So basically I have to tell DynamoDB what my partition, my primary key is. I mentioned that we could have composite primary keys that are made up of the partition key and the sort key. Another name for partition key is hash key. Then another name for sort key is range. So yeah, I have to specify that. Then I come and specify my proficient throughput, right? I have my read capacity units and my write capacity units. However, you realize when it gets to the values, I'm always having a ref. Ref is referencing the parameter. I said I can use a parameter to customize how a template behaves. So instead of writing the attribute name and type here, add code in it, I can use the parameter, which I have here. So I have a hash key element name. That means that every time I am using this template, I have to specify the hash key element name and specify the hash key element type every time. So let's go to CloudFormation and create a stack. So what we saw here is my template. I'm going to use a template to create a stack. So let's say my template is ready. I'm going to upload it. So let's upload this. Let me go to DynamoDB whilst we are here, right? Why do I think I can? Why am I thinking I can open DynamoDB? By searching for it from Google. Just to make sure we don't have any table there, and we'll say that maybe I created a table before and I'm lying to you and all that. So let's show. Okay, so there's no table. You see our tables are 0, 0, right? No table. All right, so I've uploaded this. What will happen is that I would actually send this into an S3 bucket. So CloudFormation creates an S3 bucket and then stores all the templates in there. You can view this in the designer. It gives you a graphical representation of what you are creating. So we proceed. Now to give a stack name, Bootcamp table. All right. So my hash key from last year, I think, was artist. And then this is my read capacity units, my write capacity units. We spoke about this the last time, so I don't need to tell you what it is. All right. Tags, I could specify tags. I remember I always say tag everything. So IAM rule, I've said this over and over and over that every service in AWS needs permissions to perform an activity on another service. So since we are creating resources, CloudFormation needs an IAM rule or permission to create those resources. So I could specify a particular rule, right, to do this. However, that's optional. By default, there's a service rule for this. So it would use that. If I specify a certain rule, then it will use the permissions in the rule I specify. So we could skip this. What happens when the stack fails? We say we should go back, or you could preserve the successful ones. But I think the best option here is roll back. So we can always investigate what happened and then create it again. If we preserve those that were successful, they may not necessarily work because the other components they need were not created. Okay, so there are some other advanced options here. And that notification could actually give an SNS topic. So someone asked, can we skip events bridge instead of, can we skip event bridge and use SNS directly? So you see over here, we are given the option of a notification. So we can skip event bridge. However, assuming we wanted to take something from here and then we wanted to put this in a queue, you realize that there's nothing here. However, the queue could subscribe to this topic, or you could create event bridge and then into the queue. So yeah, it's clear. That's it. Let's see if our designer is ready. Let's see how it looks. Okay. Where's that template? Okay. Why am I not seeing anything? Okay, there it is. So I can use, all right. So it's just a table. If we created a maturity application, we'd have seen the security groups and the load balancers and all that. All right. Good. So we don't have any table here. Selected a topic. Next. I just have to review this and then create a stack. Mind you, in my, over here, I didn't specify any name for the table, right? So I didn't specify a name, so to give it a name. for me. Okay. So let's go to CloudFormation and see. And the events, okay, it's created now. So it's complete. So realize just by uploading a table, I get to, just by uploading a template, a table is created for me. Now let me come and load this and see. So I have a table, Bootcamp table, my DynamoDB table. Generated a name for me. And let me click on this table. Realize my partition key is artist. Provisioned, because I specified the capacity. And my read capacity is 5, my provision capacity is 10. That's what I specified here. See, write capacity 10, default is 10, provisioned read capacity is 5. There's a max value here to control the inputs when I'm providing the values. So yeah, I created this table from CloudFormation. I could actually go and update this, right? So maybe I want to add a sort key. I say replace template, and then I still want to upload another file. So now I have a version 2, right? And let's look at the version 2. What's in the version 2? So the version 2 now has range key element name and range key element type. So that's my sort key. So under attributes definition, realize I have a second attribute and another key. I have another key here. So that's the only difference. And yeah, so now I can move on. I said parameters were customizable, right? So now I can come and set my write capacity units to 5. And then what is my range key name? So maybe that could be album title. And over here, I'm allowed to give what's allowed pattern for range element type is either S or N. So N is number. So let me do M and see what happens, because it's not in my allowed. That would feel when I proceed. So let me just come in, because we don't have time. Let me just come and specify the S. But I've changed my read capacity units and my write capacity units. I think that's all I want to change here. Let's do next. And then next. Now that changes, that's a change set, right? It's a preview. So it says it will modify my table, and then replacement is false. Okay. Let me update the stack. Let's go back to DynamoDB and see something. I have 2 tables. But the old one should vanish after the new one is created. Yeah, so it's deleting it. Because I changed it's not about the read capacity units, because I added a sort key to it. However, our change sets. Our change set said it will not modify it. So I don't know. Yeah, but there are some resources you create that when you are changing, it doesn't have to create a new version. So for instance, if let's say what's one thing, maybe if I add a tag, I come and tag a resource that I've already created, it shouldn't change the entire resource, it should just add a tag to it. But if I want to change the AMI of an instance, that one has to create a new instance for me. Yeah, so that's cloud formation. We looked at how we update, and then we looked at the change sets also. So let's take a quick 10 minutes break. And then I think we have machine learning services and the cost. Cost is very important. So maybe the machine learning service, you can just go and read it on your own. When we come back, we'll quickly look at costs and then we'll solve the question. First, we have about 4 slides only. A machine learning service, I have 3 slides with about 10 or 11 services there. You can just read this and then answer any question that comes on machine learning. It is not a machine learning or a specialty or the solutions architect professional. You just need to know what the services do. So you can go and read this. It's straightforward. Just read this. You don't have to go and learn anything again on the machine learning services for the solutions architect associate exam. Just these 3 slides should help you answer any question on machine learning services. So let's take a break. We'll be back at 12:20, and then we'll look at cost, and then we'll solve some questions. Just 5 minutes for costs, and then we'll go and solve questions. Okay, we should all be back by now. Okay, so we have about 40 minutes to finish. You realize that the initial table didn't have a sort key, but with my update, I added the sort key and then also changed the read capacity units to 5. Actually changed the write capacity units to 5. Initially it was 10. Okay, so let me delete the stack. And my table should also vanish. Okay, so there's no table. Let's see. Yeah, the table is gone. Remember that when I was setting up the CloudFormation stack, I specified some notifications, right? Which should go to my SNS topic. My SQS queue is subscribed to that topic. So it means that I can actually go and pull for messages from my queue, because my queue is subscribed to the topic. So let me go look for my queue, my SQS. Where are you? SQS. Okay, so let's go and look for messages. Realize my messages are buttons were 18. Okay, so let's pull for messages and see. Let's look at 1220. I think that was when I terminated my CloudFormation template. Yeah, so message is what? Message is, let's look for the event ID. Resource status, delete complete. Yeah. So that's when I deleted. Let's check for another one. There's also what's CloudFormation related. And the resource status is update in progress. So every status would trigger a notification to SNS, and then my SQS queue subscribe to it. So I also get it in my queue. Yeah. So I believe we get a concept. Quickly, let's look at costs, and we'll start with what? Budgets. So budgets allow you to track your costs. You get notified when your budget is reached. So maybe you say you want to spend only $10 a month on EC2, right? When you reach the $10, you get a notification. You could actually set actions for when the budget is reached, right? So maybe when you get to $10, you can set an action to automatically terminate the instance, or add an IAM rule. Sorry, add an IAM policy that denies creating of instances to a certain group or user, right? So that maybe when you reach your budget, they cannot launch any new instances or terminate some specific instance. So that's what you can do with budgets and actions. You set your budget, you get notified when the budget amount is reached. You can set actions that are automatically triggered when your budget amount is reached. So that's AWS budget. You have to know that. For example, cost and utilize usage reports, right? So that contains a comprehensive set of all your spend, all your cost and usage data. We get that from cost and usage reports. So you can receive reports at intervals you set, whether hourly or daily or monthly. And cost and usage reports can deliver your cost and usage reports to an AWS bucket, S3 bucket, or to update your cost and usage report 3 times a day, up to 3 times a day. You can also use an API to get your costs and usage. Now, Cost Explorer is similar to costs and usage reports. The difference here is that with Cost Explorer, you can decide to have a detailed or a summary of your costs, right? And then you can also create custom reports. And it has visualization. So you can visualize your costs, understand your cost trend over time, right? Cost and usage reports will give you very detailed reports of your costs. Cost Explorer can give you detailed or a high level if you want. The difference is that costs and usage reports, you can deliver your cost report to an S3 bucket. Cost Explorer gives you visualization for your costs. So you have to know the difference. They do almost the same thing. Okay. Savings plan, we looked at this. Okay. So savings plan basically would allow, I'll have to update that slide. Savings plan gives you discounts when you commit to a certain utilization. So maybe over time, you use maybe $100 or you spend $100 on AWS a day on EC2. So with savings plan, you can commit to spending $100 or $10 an hour, and then you get some discounts for that. Once you spend that amount, automatically it's applied to your bill. We looked at this when we treated compute. So we won't spend much time here. All right, now let's look at some exam questions. So the exam questions, you are the ones who answer them, right? And then we'll all discuss. Let me make sure I have terminated the resources I created for today's event. So exam questions coming up. Okay. The last thing I need to delete is my SQL queue. And then, yeah, okay. All right, after I delete this, the next topic. I believe I still have an delete. Still have an instance running. So EC2. All right. So we are warming up for the questions. Let's start with the new exam. SAACO3 is the new one. So let's start with that one. And these are sample exam questions from AWS. So they're in the public domain. Our first question says that a company runs a public-facing 3-tier web application, a VPC, across multiple availability zones. Let's pause here. This is what we did last week, right? We ran a 3-tier web application. Okay. Amazon EC2 instances for the application tier running in private subnets need to download software patches from the internet. Remember, I ran sudo yam updates. However, the instances cannot be directly accessed from the internet. Which actions should be taken to allow the EC2 instance to download the needed patches? Select 2. First option is configure a NAT gateway in the public subnet. B is, we have to select 2. B is define a custom route table with a route to the NAT gateway for internet traffic and associate it with the private subnets for the application tier. C, assign elastic IP address to the EC2 instances. D, define a custom route table with a route to the internet gateway for internet traffic and associate it with the private subnets for the application tier. E, configure a NAT instance in a private subnet. Who is brave enough to give us the 2 answers? Yes, I like Joey's braveness. So I see Joey. Who else do I see there? See somebody. Let's see. Joey raised up his hand first. There's also Daniel Kumsin. Okay, so Joey, we have men here. Yes, good. Kenny. Okay, so Joey, no, Joey, go ahead and then answer the question.
The answer is A and B.
A and B. Can you explain? Have you seen this? Have you seen this question before? First of all,
a similar one, but
okay.
They look
all right.
alike.
All right. So why A and B?
Because you cannot for the private subnet to get internet, it needs access to internet via the public subnet through using a NAT gateway. And you have to define the route of the NAT gateway from the internet to the custom table so that it can point to the application tier.
Okay. I think maybe the explanation is not what it is, the last part, but you get the concept. So that is true. First of all, an instance in a private subnet, when it needs internet access, you would have to use a NAT gateway or a NAT instance. The NAT gateway has to be in a public subnet. A public subnet has a route to internet gateway. So if the NAT gateway or the NAT instance is in the public subnet, then by default, there'll be a route to the internet gateway. That will take care of it. For your private subnet, you have to create a route table that sends internet traffic to the NAT gateway. And you associate that route table with your private subnet you want to give internet to. Your NAT gateway, you would always associate an elastic IP address with it. So these are the concepts you need to know to answer the question. However, you realize that C says assign elastic IP address to the EC2 instance. That will not solve your problem because the instances are in a private subnet. If you are assigning elastic, yes, elastic IP is a public IP, but it has no route to the internet, so it won't work. This says you should define a custom route table with routes to the internet gateway. So technically, this will work. However, when you a subnet with a route to the internet gateway is a public subnet. So it refuses to become a private subnet when you define a route to the internet gateway. Secondly, when you define a route to the internet gateway and your instance has a public IP, that means that now it can be accessed from the internet, directly from the internet. The question says that it shouldn't, the EC2 instances cannot be directly accessed from the internet. So D would not give you this. And then E says you should configure a NAT instance. When you read configure a NAT instance, that seems correct until you see in a private subnet. You don't configure NAT instance or NAT gateway in a private subnet. You do that in a public subnet. So yes, Joey got the first one right. Now let's look at question 2. Question 2. A solutions architect wants to design a solution to save costs for Amazon EC2 instances that do not need to run during a 2-week company shutdown. You remember sustainability pillar and then cost optimization. Okay. And operational efficiency. This question is, the first question will fall under security primarily. This has like 3 pillars. The application running on EC2 instances store data in instance memory. That must be present when the instances resume operation. Which approach should the solutions architect recommend to shut down and resume the instance? Joey, please lower your hand there. For now, we need to get other people to answer your question. You've answered one already, so for now, you lower your hand. Okay, I see Kenwood. Let's look at the options. A, please mute your mic till I call you. I want to take us through the options. Not everybody can see, may be able to read. So let me give the options first and then. So A is modify the application to store the data on instance store volumes. Reattach the volumes while restarting them. B, snapshot the EC2 instance before stopping them. Restore the snapshot after restarting the instance. C, run the applications on EC2 instances enabled for hibernation. Hibernate the instance before the 2-week company shuts down. D, note the AZ for each EC2 instance before stopping it. Restart the instances in the same AZ after the 2-week company shuts down. Now let's see who answered this. I have like 3 people raise their hand. So, okay, Kenwood, Daniel, don't worry, I'll call you later, okay? Kenwood, go ahead.
Okay, I'll go for the run the application on EC2 instances enabled for hibernation. Then
Okay.
hibernate the instances before.
Why will you go for that one?
With hibernation, you will not lose your data when your system goes for hibernation.
Okay.
Yeah.
More particularly, you will not lose your data in memory. Whilst the question talks about in instance memory. So yes, it's true, you not lose your data. Yes, your data in memory, you not lose it when it goes to hibernation. Because the question says it's not asking you to change how the application is running, right? So A will not be correct because we don't want to store the data on volumes. We want to keep it in the memory. And then B says snapshot the. Why is B wrong? Anyone? I have two hands raised, so I believe Daniel. Why is B wrong? Daniel Clements, why is B wrong? Should I unmute? Oh, okay, we can't hear you. So, Kenwood, why is B wrong? You're the only other person who has his hand raised up.
Okay. For the B, it talks about snapshot, and snapshot is more of backup.
Of what?
Backup of the instance.
Okay, the volume. The volume.
Okay.
Yeah, the volume is the disk you store data on, either SSD or hard disk. So snapshots would back that one up or copy that. All right. B is also wrong because when you stop an instance, whatever was in memory is lost. So if you come and start it again, you not get whatever was in memory, right? And then it says note the AZ for the instance before stopping it, which starts in the same AZ. That's putting you off. Let me mute Daniel. Daniel, we can't hear you, so you let me mute you, okay? So yes, we've answered 2 questions correctly. Question 3, a company plans to run a monitoring application on EC2 instance in a VPC. Interesting. Connections are made to the EC2 instance using the instance's private IP version 4 address. A solutions architect needs to design a solution that would allow traffic to be quickly directed to a standby EC2 instance if the application fails and becomes unreachable. Wow. I like this question. Let me read the last sentence again. A solution architect needs to design a solution that will allow traffic to be quickly directed to a standby EC2 instance if the application fails and becomes unreachable. Which approach will meet these requirements? So the first one says you should deploy an ALB configured with a listener for the private IP address and register the primary EC2 instance with the load balancer. Upon failure, you register the instance and register the standby instance. So let me give you a clue here, okay? Even before I continue. Whenever you are asked a question, okay, usually you take the ones that are wrong. Some of them are wrong. You can, when you read them, you can just see that they are wrong. You take them out. Secondly, usually when the question involves so many manual steps, it is wrong. If it involves so many manual steps, it's usually wrong. Okay. So let's continue with the options. Configure a custom DHCP option set. Configure DHCP to assign the same private IP address to standby instance when the primary EC2 instance fails. C, attach a secondary elastic network interface to the EC2 instance configured with a private IP address. Move the network interface to the standby interface if the primary EC2 instance becomes unavailable. And then D, associate an elastic IP address with the network interface of the primary EC2 instance. They associate the elastic IP from the primary instance upon failure and associate it with the standby instance. I don't see any hands up. Today, do we have any lady here? Oh, I think they dropped off. There's no lady. Or there's a lady I'm not seeing. Okay, there's a hand up. The person lowered their hand. Who raised their hand? Any other? We want everybody to attempt. Okay. Yeah, Daniel, go ahead.
I'll go for the B to
You go for
configure
the
the
B.
console.
You know, when you select your answer, you have to explain. Why B? When you pass the Solutions Architect Associate exam, do you know what it means?
Charlie.
It means that you understand AWS and you can architect very simple solutions, right? If I say simple, pardon me. And it also means that you understand the theory around how the various components work. Some of the components are not necessarily primarily to AWS, they are general IT principles. So every answer, you don't do guesswork in the exam. You select options because you understand the option. You know what it is. That's what you do when you are in such a situation. So why B? Defend your answer.
I'm running away from the defense.
You're running away from what?
The defense already. So
You're running away.
With the custom-based system, I think because we are looking at
who is talking? Daniel. I think I have two people. Let me mute. Is Daniel Kumsun who answered the question, right?
Yes.
Okay. So why is the other guy not? Okay, I've muted him. Good. Okay, so Daniel Clement, please mute your mic. We can't hear you. Why is it not muted?
Hello?
Yeah. Who's talking now?
Daniel Kumson.
Okay, good. So you say you're running away from the defense.
Yeah, but don't worry, I'll stand and fight.
Okay, yes, fight. Let's go.
So
like
with the DHCP option, you see, because we are running the IPv4 address for the instance, and we are looking at the option of that when one fails, it will directly move to the primary one. So in the solution, you have to know that both the EC2 instances will have the elastic IP address would have worked, but in this instance, we are looking at a way that the routing will just move straightly to the standby. So I think the best way to go about it is to configure. Yes.
So let's look at this. Let's explore this further, right? It says configure DHCP to assign the same private IP address to the standby instance when the primary instance fails. So you can't configure DHCP to assign a specific IP when you are creating a standby instance, right? Or when you are creating another instance. There's no way to configure it to ensure that when you are creating the instance, it would assign it to the private IP to it. Okay. Secondly, assuming your standby instance, I think that should have been my first statement. You know, you don't want to create your standby instance. You don't want to create your standby instance after the instance fails. It means that it will take a while, right? So maybe you get notified that your primary instance has failed. Now it takes you 5 minutes to log in into your computer to now come and create the standby. So usually you have it's called standby because it is already running, just that it's not the active one. When the active one goes down, then it kicks in. So your standby instance should be running alongside your primary instance. Once it is running alongside your primary instance, it means that you can't use two IPs. You can't use the same IP for two instances, right? Right? You can't do that. So yes, that will not work because the two should be running at the same time. I see now we've eliminated one answer. Kenwood.
Okay, so let me give it a try. The question says that a company plans to run a monitoring application. So I'm looking at this monitoring as a keyword, and then
I don't think the monitoring should be the keyword.
oh, okay,
The keyword should be private IP address
okay,
and failing over to the standby instance. I think those are the two. It could have been an e-commerce application or something. It could be something else.
yeah.
So what?
One here.
Or you want Joey to come and help you?
Yeah. It's quite technical.
Okay, Joey, over to you.
Okay. This one is.
Oh, you're all guessing.
No, this one I'm not guessing, but I'm sure. But I'll be shocked if that is not the answer. So
You'll
I'll
be
go with an
shocked
A.
You'll be shocked if that is not the answer.
Yes.
Okay, A is not the answer.
Samaba. Because
It looks
the
like
reason why.
Okay, why A?
The reason why I chose A was because when you are off all the, just to elimination, I'm just using a technique to eliminate all of them. And first of all, when it comes to configuration, it means when, as if you've already done it before, like it's something like you've automated.
Yeah.
Okay, then attach is when it happens, when the damage is already done, that's when you are coming to resolve it. Then associate is like, it's almost like the same thing, but when it comes to deployment, it's like when you are deploying, the process of deploying the process, you already configure all these things. So, but
okay.
Should I go on?
Let me help you, okay?
Okay, please go ahead.
It is true that when we're doing our bootcamp, I think we only looked at application load balancer. But what I said about application load balancer is that it only works with HTTP protocol or HTTPS protocol. And the network load balancer works with any TCP protocol, right? Or even UDP, right? Good. So it is possible that our monitoring application is not running HTTP. So application load balancer will not work for us. Also, I told you that the answer involves manual process, but anything that has to do with a lot of manual stuff is usually not the answer. When you use, secondly, when you use an application load balancer, let's go back to the question, right? Connections are made to the EC2 instance using instances private IP address. So even if you bring in a network load balancer, you are oversolving the problem. They said use the private IP address. If the load balancer is a public load balancer, then it means that it may have a public DNS and a public IP address. You are going through another system to connect to the instance. It says you should connect to it directly using the private IP version 4. The elastic IP is a public IP address, so that will not work also. You don't solve the problem. It says you use the private IP address. So by using elimination, you realize that only C is left. You people claim you're using elimination. And your options are eliminated.
On second thought, I saw something in the C. So I was like, oh, that was the word. That was the first sentence.
Attach. So we didn't look at network interfaces. Maybe we did by didn't mention. When we created the VPC endpoints, what it did was actually create network interfaces into our VPC. your EC2 instance can have multiple network interfaces, right? So if in such a situation where you want to use a specific private IP address, you can have a secondary network interface. And that's where that will have a private IP address. And then when you want to move it around, you can move that network interface onto another instance and still keep that same private IP address. So the instance, those connecting to your monitoring application or the instance that hosts your monitoring application, all they need to know is the private IP. And then if it fails, you can just go and take your network interface. It exists on its own, even though you can attach it to the instance. If your instance fails, you can just go and take the network interface and then move it onto another EC2 instance. So that's the answer. I think most of us were over solving the problem. The problem is, this is a keyword, instance private IP, and it should be directed to the standby instance. I think those were the two keywords. Yeah, Joey, anything you want to add or question?
Yes, but doesn't it defeat the purpose of automation in terms of operational excellence?
Good.
Not.
So this can actually be automated. It will involve some serious scripting here and there to do it. But yes, it can be automated. But given the scenario, there's only C that addresses the scenario. Every other option either oversolves the problem or it either oversolves it or the theory behind it won't work in practice, right? Okay. So moving on. An analytics company is planning to offer a web analytics service to its users. The service will require the user's web page include a JavaScript script that makes authenticated GET requests to the company's S3 buckets. What must a solutions architect do to ensure the script will successfully execute? What do you think the answer is? Who knows the answer? Who has the hand up? Like I told you, first of all, start with elimination. Daniel, when you speak, we don't hear you. So maybe you can type, Daniel, you can type your answer. You are the first option. You are my first choice to answer this question. So you type the answer in the chat. And please mute yourself. Okay, so whilst Daniel is typing the answer, is he typing? Daniel, we're waiting for you. Otherwise, I'll call somebody else. Who else has their hand up? Okay. We'll give Daniel 5 seconds. If we don't see his answer, we'll call Nanaiko. 1, 2, 3, 4, 5. So Nanaiko, what do you think? What will you choose?
Using elimination, I will guess that it will be A, because I understand all the others apart from A clearly. And I know that all the rest will not solve the problem.
I like your explanation. Okay, so it's A.
Elimination will not solve it.
It's actually A. So there's a concept called cross-origin resource sharing, right? If you're a developer, you realize that it's a nuisance. What it is that by default, you can't access by default, when you have, let's say, JavaScript code running, right, in your application, right, you can't access another resource, or when a JavaScript script from another URL tries to access another script from another domain, by default, that is denied. It's not just AWS, right? It's how it works. Just to prevent, it's a security measure. So usually you enable CORS to allow the cross access or cross-origin share. So that's what it is. And S3 has this feature also to enable such use cases. So yes, A is correct. Versioning will not solve this problem. Yes, there's a pre-signed URL for S3, but it won't solve this problem because, or it's not sustainable because pre-signed would usually have an expiry date. And then configure an S3 bucket policy to, this is dangerous. When you see that option, run away. Okay. A company's
No, I want to say something. I don't know, so that
who is okay, yes, go ahead.
so I understand that with the cross origin, it's normally associated with CloudFront. The origin identification access, cross origins, all come with CloudFront. So when you're dealing with S3 buckets and it has to do with GET requests, you have to look at anything that CloudFront offers
it's not only CloudFront that can access S3, right? And this question specifically says your service is accessing S3 directly. So there's no CloudFront here.
No, but it talked about GET request. I don't know if
do you know that you can use S3 buckets to host an application?
Yes.
Okay,
but
good.
In that case, you can make the S3 the origin. The S3 buckets the origin.
Oh, okay. So the CloudFront origin is what is confusing you here.
Yeah.
Cross-origin resource sharing has nothing to do with CloudFront.
Okay.
CloudFront, or they exist in isolation, let me put it that way. CORS was there before AWS. It applies to other applications, even outside AWS, right? CloudFront has what you call origins. That's where your application is hosted. That's usually your S3 buckets or your load balancer. So that's origin in CloudFront. But this concept is a general IT concept, not necessarily associated with CloudFront. Okay.
Okay, thank you.
All right. So it's one. Let's look at our next question. We didn't look at KMS, but let's see if we can answer this question. The company's security team requires that all data in the cloud be encrypted at rest at all times using encryption keys stored on premises. Interesting. Which encryption options meet these requirements? It says you select two. So we have server-side encryption with S3. We have server-side encryption with KMS, AWS KMS managed encryption keys. Then we have server-side encryption with customer-provided encryption keys. And then we have client-side encryption to provide encryption at rest. Okay. And then use S3 Lambda function invoked by S3 event to encrypt the data using the customer's keys. Interesting. So which one is our answer? I see, who do I see here? Naneko answered the other one, right? It looks like only 4 or 5 people are. Okay, Emmanuel, you have to defend your answer.
Okay, so I'm thinking it's B and then C.
It says that it says using encryption keys stored on premises.
On
So
premises.
your
Yeah.
encryption key should always be customer focused.
Yeah. Yeah. So I'm thinking
But B is not customer focused. It's
the KMS.
server-side encryption with AWS KMS. You are still using AWS managed, even it says managed encryption keys. So the keys are provided by AWS.
But I think with the KMS, you also have the option to provide a customer managed key for that one. Oh,
Yes.
yeah.
But this
So
managed encryption keys, it says AWS KMS managed encryption keys. That's not it.
oh, okay.
Yeah. So the answer is actually C and D. C says you use server-side encryption altogether. So that's what you are referring to with customer-provided encryption keys. That's what you are referring to. Yeah, you are referring to. Then the next one is to use client-side encryption to provide at-rest encryption. So it means this one, you are handling the encryption on your own. It's not going through KMS. Because your keys are on-prem. So it means that you have an application that will be doing the encryption with your own keys. And then you store them at rest in AWS. If you want to retrieve them and decrypt them, you have a process, you manage a process to decrypt or get the key to decrypt the data. So that's client-side encryption. Quickly, let's move on to a question on reserved instances. This question will be answered by Paco. I didn't give him the chance to answer the other one, so you should get ready. A company uses EC2 reserved instances to run its data processing workload. The nightly job typically takes 7 hours to run and must finish within a 10-hour time window. The company anticipates temporary increase in demand at the end of each month that will cause the job to run over time limits with the capacity of the current resources. Once started, the processing job cannot be interrupted before completion. That statement is very, very important. It will tell you some of the answers to eliminate. Once started, the processing job cannot be interrupted before completion. The company wants to implement a solution that would provide increased resource capacity as cost effectively as possible. So it's a long question, but the takeaway is that the company is already using reserved instances, and with these reserved instances run a job that usually takes 7 hours to run and must finish within 10 hours, right? And towards the end of each month, they expect that there will be an increase in demand, right? And the job will run over the time limits that they put there. It says that once the job is started, it cannot be completed. So first of all, Parker will tell me which option that particular statement will eliminate from the options. And they want this to be cost effectively, they want it to be cost effective as possible, right? So they are using reserved instance, but it's not, they want it to be cost effective. So yeah, Parker, over to you. Unmute your mic. Or you don't want to attempt this one?
Let me try.
Okay.
Yeah, so since they are already using reserved instances, C will not be correct because spot instances, they don't want it to be interrupted before completion.
Okay, good. Yeah, so that's the first elimination. Good.
Yes, and see, me, I'm going for the fact that since they are still already using reserve instances, then I'm guessing they should increase the size.
Okay, you've eliminated one and then given an answer which is wrong, actually. So means that we are left with two options. Since we are left with two options, anybody can guess one of. There's a 50% chance of guessing the correct one, right? So the correct answer is actually A, and I'll explain why it is A.
Okay.
You use reserved instances when your application is running all the time. Is that okay? So like database, the database is running all the time. If you run a web application or a web server, maybe at least two instances should run all the time, right? So you can use reserved instances for that. However, this workload only runs 7 hours and the maximum is like 10 hours every night. So using reserved instances would mean that the instance is there and is not being used till that time. So when you use on demand, you could actually only launch the instances when it's time to do the job. And you pay for the time that it is running. Do you get it? And sports doesn't qualify for this because the application cannot be interrupted. Sports instance, when the spot price is reached, then the application, your instance may be terminated because your sports price, the price you give is no longer valid, right? So the answer is A. Robert, I think you have a comment on this, so go ahead.
I want to inquire. I agree that the answer is the on-demand, but I'm also looking at if there was an option for the scheduled reserved instances, could that have been a better choice? Since they are saying that at the end of each month, that will cost. So it's like we know beforehand that at the end of each month, we are going to get this jump. So could we schedule a reserved instance for just that period, which will save us more money than using the on-demand instances?
But even if you schedule the reserved instances, right, the application is not going to run the whole day.
Okay.
This temporary increase in demand, that will cause the job to run over its time limit.
Okay.
Yeah, it's just running over its time limits. Even if it says it never crosses, mind you, it never crosses 10 hours, but it typically takes 7 hours. So even if this is ambiguous and it runs over its time limits, it will not even be the whole day, right? So yeah, scheduled reserved instances will still not be cost effective, even though it's a better option than some of the ones we saw. 7.
Thank you.
All right. A company runs an online voting system for weekly live television program. During broadcasts, users submit hundreds of thousands of votes within minutes to a front-end fleet of Amazon instances, EC2 instances that run in an auto-scaling group. The EC2 instances write the votes to an Amazon RDS database. However, the database is unable to keep up with the request that comes from EC2 instances. Very good. We are now coming to, when you answer this question here, it means that you understand the things we've learned. A solution architect must design a solution that processes the votes in the most efficient manner without downtime. So the first option is to migrate to Lambda. You use API gateway to route user requests to Lambda functions. Okay. And then B is scale the database horizontally by converting it to a multi-AZ. Configure the front-end application to write to both the primary and secondary DB. Interesting. C, configure the front-end application to send votes to SQS provision worker instances to read the SQS and write the vote information to the database. D, event bridge, to create a scheduled event to reprovision the database with larger memory optimized instances during vote periods. When voting ends, reprovision the database to smaller instances. Ejuma. Okay, so I see two hands up. Who are two architects? Kenwood, and it's only left to Kenwood. Okay, Kenwood, take this.
Okay, so for me, I'll go for C.
Okay, why C?
Yeah.
Why C?
C because the question says that the database is unable to keep up with the requests that come from the EC2 instances.
Yeah.
And in this situation, using the Amazon Simple Queue services, we'll be able to manage the number of votes that come in. Yeah, so that the RDS wouldn't be too
overwhelmed.
Yes.
Okay, so yeah, C is the answer, and this is a typical use case of SQS. And so yeah, we learned about SQS today. In real life, this is what you do with SQS. All right, because of time, I won't talk much. Let's move on. A company has a two-tier application that runs in the public and private subnets. So last week, I mentioned, when we did the three-tier, I mentioned that if you say two-tier, that means that the application and web layers are combined together, and then you have a database. Good. Your database should always be in a private subnet. So have that in mind. Amazon EC2 instances running web applications are in the public subnet, and the EC2 instance for database runs on the private subnet. The web application instances and the database are running in a single availability zone. Which combination of steps should a solutions architect take to provide high availability for this architecture? This is a very simple question, right? So who do we have? We have to select two options. The first one is create public and private subnets in the same AZ. Creates EC2 auto scaling group and ALB spanning multiple AZs for the web application. C, add existing web application instances to the auto scaling group behind an ALB. D, create new public and private subnets in a new AZ. Create a database using EC2 instance in the public subnet in the new AZ. Migrate old database contents to new database. E, create new public and private subnets in the same VPC, each in new AZ. Create an RDS multi-AZ instance in the private subnets. Migrate the old database contents to the new database. So who do we have? Nana Eko. You have to select two options and defend your selection.
Okay. So for availability, I know multi-AZ is always preferred.
Mm-hmm.
So A is obviously out. And then, so I'll go for B. For B.
Okay, good. You go for B, right? Create an Amazon EC2 auto scaling group and ALB spanning multi-AZs for the web application instance. Yeah, that's correct.
Then D and E also look similar.
So yes, so now that's where you have to apply best practices. I said earlier that options that require you to do a lot of work are usually not the right option. Okay. And now we're also talking about you said in your first submission, you said that multi-AZ is always good for high availability. So which of the two options will give you?
That should be E then.
E, good. And you always use a managed service
Yeah.
rather than doing things on your own, right? So
Yes.
D says that create new public and private subnets in a new AZ. Create a database using EC2 instance in the public subnet. You see, public subnet. That alone should have given it, and then migrate the old database contents to the new database. There are a lot of things wrong with this option, right? First of all, it's only going to be in one AZ. Secondly, you are running your database on EC2. And it means that you have to, when we treated databases on Thursday, you saw the things you have to do when you are running your database on EC2 instead of using RDS. It's a lot of work. So that's also wrong. E says we should create RDS in multi-AZ. So that's good. You have high availability there in private subnets, and then you migrate your old database to the new. Yeah, so is B and E. All right, 2 questions and then we'll close. A website runs a custom web application that receives a burst of traffic each day at noon. The users upload new pictures and content daily, but have been complaining of timeouts. The architecture uses EC2 auto-scaling groups, and the application consistently takes 1 minute to initiate upon boot up before responding to user requests. Interesting. This is a very simple question with a very simple answer. How should the solutions architect redesign the architecture to better respond to changing traffic? First of all, it says you should use a network load balancer with slow start configuration. Interesting. Configure Elastic Cache for Redis to offload direct user requests from the EC2 instances. C, create an auto-scaling step scaling policy with EC2 instance warm-up condition. And then D is you configure CloudFront to use ALB as the origin. Always remember that you defend your answer. So Daniel Kumsin, over to you. What's the?
I think it boils down to my earlier CloudFront and using the ALB as the origin.
Okay. What would that solve?
So it will solve the issue of, you see, the CloudFront is a content delivery network. So in terms of the uploading the new pictures and the content daily, the content delivery will cache a lot of the in the CloudFront. And making sure the ALB becomes the origin makes sure that it doesn't bypass
Okay, I get you. Now let's go back and read the question. A new website runs a custom web application that receives a burst of traffic each day at noon. The users upload new pictures and content daily. So they upload new pictures here. CloudFront is a cache. Cache is when cache works for when you are reading or downloading traffic, right? This time around, you are uploading, you are sending pictures. Do you get it? So the cache will not work here. Is that okay?
Yeah.
Good. So that also means that Elastic Cache is also out.
Yeah.
Okay. Now, auto scaling is the correct answer with the warm-up condition. It says when they mention the application consistently takes 1 minute to initiate upon boot up before responding to traffic. The warm-up will allow it to initiate or go through that 1 minute process of boot up and be ready to respond to request and be added as a healthy target in the auto scaling group, right? So that's the correct answer.
But please, with the step scaling, I understand that it is being triggered by events. That's when the step scaling becomes an ideal.
Okay. So steps, yes. So steps take the most important thing is the auto scaling. Step scaling is one way to do auto scaling. What happens is that you could say that when your CPU utilization is 50%, average CPU utilization is 50%, you should add one instance to the auto scaling group. If it gets to 60, we should add 2. So it is in steps. That's what it's all about. And this solves the problem, right? Because you keep adding instances when your traffic is increasing, and you respond automatically to increase traffic. Question number 10. An application running on AWS uses Amazon Aurora multi-AZDB cluster deployment for its database. When evaluating performance metrics, a solution architect discovered that the database reads are causing high I/O and adding latency to the write request against the database. How do we solve this problem? What should the solutions architects do to separate the read request from the write request? This is easy. A, enable read-through cache on the Aurora database. B, update the application to read from multi-AZ standby instance. Create an Aurora replica and modify the application to use the appropriate endpoints. Create a second Aurora database and link it to the primary database as a read replica. I only see Nanayako's hand up. So Nanayako, take it away. I believe you're here on Thursday. That's why you quickly raised up your hand.
Yes, so straight away, when I read about the reads and reducing latency, I think of the replicas, Aurora replica. So
okay.
I'll quickly go for C.
Okay, that's correct. Why not B, which talks about multi-AZ? I want to rehash something. That's why I'm asking this.
I think that would be an overkill. We don't need to.
Okay. That's not the answer I'm expecting, actually. Anyone who can help us with that?
So
why not
Aurora,
multi? Okay, go ahead. Someone else.
Aurora itself, it's a database engine. It creates its own replicas. So, and its replicas are in 3 availability zones in each region. So
okay,
we can't create multi-AZ standby instance for it because it has its own.
The question didn't say you should create a multi-AZ. It says update the application to read from the multi-AZ standby instance.
Okay.
So it's already there. You know that Aurora multi-AZ will have a standby instance and all that. But this is about updating the application to read from the multi-AZ. There's a particular answer I'm expecting. If someone gives, Joey. Joey, how many sessions have you been here?
This is my second session.
This is your second, but it looks like you've been here. You are quite engaging. So answer this question and let's see what I can do for you. Okay, go ahead.
The answer is A.
We've already given the answer. We are just explaining why the answer is not B. The answer is C, actually. So we are explaining why it is not B. Foster, you raised your hand. I think you wanted to attempt that question, right? Why is it not B, multi-AZ standby, updating the application to? Or you don't want to answer again? Okay.
I thought the answer was wrong as well. So
No. The C is correct.
The caching as well.
C is very correct.
Okay.
We are discussing why it is not B. So there is multi-AZ standby is not used for reads. That's one thing I want you to understand. It's not used for reads, actually.
It's for high availability.
Yes, it's for high availability, so that when the primary instance fails, the endpoints will now be directed to the standby. So it's for failover. It is there purposely to be used if there's a failure, not when the primary one is working. So that's one thing you should understand. It's for high availability, not for reads. Yeah, Joey, go ahead then.
The reason why I chose the read-through caching on the Aurora database was because they said architect to separate the read request from the write request. So I thought that would suffice.
You use read replicas for that, not read-through cache. Besides, let's see, Aurora read-through caching. I don't think I've found what I'm looking for. Then let's go back to the question, okay? Okay. So you have to be careful with caching, okay? So caching is used to reduce latency when it comes to reads, right? And not just database anyway. And maybe for sessions and all that, right? So what happens when you want to access data that's not in the cache? It goes to the original source and then gets it and puts it in the cache and all that. However, when it comes to your databases, like Aurora and RDS, your primary way to scale reads or reduce latency on reads is using the read replicas. If the same data is being read over and over and over and over again, that's when you could consider using the caching. Okay. All right. So I think we've solved all the 10 questions, and we use this to explain some of the concepts we've learned already, and even some that we've not looked at before. So if there are no questions, we'll end here. I will share the slides, and the slides will have resources to prepare you for your exams also. So yeah, thank you all for attending this.
Please, where will you share the slides?
You get this latest tomorrow morning, but likely this evening.
Okay. I'm writing next week, Friday, so Charlie.
Okay. All right. All the best. Which one are you writing? Solutions Architect Associate?
Yeah, solutions.
Okay. All the best.
Charlie, thanks.
All
last
right.
Minute.
You came for last minute appointment. Okay,
Charlie,
that's good. All right. So thanks, guys, for attending. Let's keep engaging in the Slack channels. I've seen some people have sent me some messages. I've not responded yet. Now I have time to come and respond. So I'll come and respond. Okay. Yeah. So thank you all for attending, and see you soon.
Thank you.
Bye.